So today we're going to start our square root function unit and radicals and the quadratic formula. And we're going to just start by looking at our square root function. So square roots are the natural inverses of squaring. So like x squared and square root, they're inverses of each other. Okay. I want you to think about that as we are looking at this unit, just because it's important to understand their graphs and then their domains and ranges as well. So that's what we're going to look at on this first one. Okay, consider the two functions, square root of x, and then we have the square root of x plus 3 minus 2. So without the use of our calculator, we are going to graph that function, the square root of x. So maybe an easy way to think about this is if we were to just, oops, daisies. Okay, if we were to just think about f of 0. So if I were to do the square root of 0, I know I get 0. Okay, so there's coordinate. If I did the f of 1, so the square root of 1 gives me 1. Okay, so oops, there's another coordinate. Now I'm going to do some nice numbers here. So for instance, 4, because I know the square root of 4 is going to give me 2. That gives me just some nice numbers to graph, again, without the use of my calculator. For instance, another one, the square root of 9. And notice why maybe I'm picking these numbers, because I know that they're perfect squares, meaning they're going to work out nice and easy when I graph them. So if I were to graph a couple of points, I have 0, 0, 1, 1, over 4 up 2, over 9, so here's 5, 6, 7, 8, 9, up 3, and we're going to get our graph with an arrow. Okay, make sure we have a label for that as well. Notice I didn't take any negative numbers because we know if I were to say the f of negative 1, that's going to be undefined. So I can't really do too much more with that one. Okay, so using your calculator, we're going to try and generate a table of values on the same grid and label its equation. Now, here's what I'm actually going to say. Before we do the table of values and before we do anything like that, let's go back to our previous unit and think, what is this graph asking us to do in terms of transformations? So if I were to think of this one here, x plus 3, so it's with the x, I know it's going to be a horizontal motion, and horizontal is opposite, so I'm thinking that's going to go left 3. Now this is at the end of the graph, or outside of that function, so I know that that's going to be vertical, and verticals are normal, so that's got to go down 2. So I'm going to take all of these coordinates here, and I'm going to take them and go left 3, down 2. So for the one at the origin, if I go left 3, down 2, here's a point. I'm going to take 1, 1 and go left 3 and down 2. Here's my next point. Okay, for the coordinate over here at 4, 2, I'm going to go left 3 and down 2. Notice where that one hits. Okay, for this next one here, I'm going to go left 3 and down 2. So again, taking all of these points and graphing them, and we just did that strictly by thinking, what are those transformations? Okay, we got our new graph. So we are going to go to the calculator, and we're going to take a look at this. And in fact, those are the graphs that we got. If I were to take a look at the table, now it said start the table off at negative 10. Well, check out what happens with negative 10. All right, negative 10, if I were to look at some of these values, I'm getting some imaginary numbers. I get like an I value here. And over here, if I take a look and I highlight it again, I'm getting an imaginary value. That means it doesn't exist. Okay, and it's not until I get down to, check this out, our first location at negative 3, negative 2, that was our first point that we plotted, that I actually get a real value. Okay, so we saw that just through the basics of transformations. We can see by graphing it and checking it out on the table that those would be our values. So the next thing it's asking us is for our domain and range. Okay, so for the domain and range, we're going to do it for our original function for the square root of x. Domain, remember, are going to be your x values, and range is going to be your y values. Okay, so if I were to go back up to your graph and take a look at the domain for my red function, it looks like I'm not going anywhere below 0, but I can include 0. And I'm going to go all the way out to infinity. So for my domain for this, and it says using set builder notation. So proper set builder notation, remember we get that x such that. And we're going to say here x is greater than or equal to 0. Okay, so for your range, we're looking for your y values. So again, I'm going to look at that red graph. And the lowest y value I have here at the origin is 0. And it looks like it keeps increasing. Now, it's going to keep increasing very slowly, but it's going to keep increasing. There is no bound to that graph. So for your range and set builder notation, remember we just have to make sure we're using the y. And I have less than again, or I'm sorry, greater than or equal to 0. Okay, so now how does that change for your domain? Well, let's think about what we had to do on our domain. Our domain, we said with all of these transformations, we had to go left 3 and down 2. Well, that left 3 shifts your domain, so now my lowest possible x value here is at -3. Okay, so by going left 3, again, I'm like subtracting 3 from 0. So now your domain on this graph is going to be anything greater than or equal to -3. And now when we look back at the range, again, let's think transformations. So we said we had to go left 3 and down 2. That down 2 is now affecting, again, our y values, meaning now my lowest y value here is at -2, and it increases up. So I can tell you for the range, our y's, such that y has to be greater than or equal to -2. So remember from our transformations what we said. We had to go left 3, and we had to go down 2, and you can see how that is affecting your domain and range. Okay, try our next one here. So it says, which of the following equations would represent the graph shown? All right, so again, to me, this is your square root function, but I see a couple of things have been happening. Two things I see. It looks like that coordinate has been shifted to the left 4. So I'm just going to write these down so I get an idea. And now I'm also seeing it looks like it was reflected over the x-axis. So if I'm reflecting over the x-axis, I want to think to myself that's like negating the y. And if I negate the y, I write this down, if we negate the y, that's like negating your f of x. So think about that. I'm negating the entire function, meaning I would want a negative in front of that entire function. So I would have to get rid of 3 because I actually don't see a negative whatsoever in front of my entire function. Notice I have a negative in front, a negative in front, and a negative in front. Now, if I'm going left 4, that is going to be affecting your horizontal axis. And horizontal axis, notice again, it's on that x-axis, meaning it has to be with your x values. And if it's horizontal, it's opposite. So I want to think left 4, even though it looks like it's in the negative direction, opposite of that should be positive. We're going to have choice number 1. This one here would actually be telling you right 4. And this, notice it's on the outside, it's not underneath that square root, that would be telling me up 4. So that's the difference with all of those. Okay. So we are going to take a look at how we had that, can have a negative number under a square root, and it says the square roots are with negative numbers do not exist in the real number system. And as we progress into our next unit, we're going to see how actually we can change that. So it says, which of the following values of x does not lie in the domain of that function? So now think about what we said. I cannot have a negative under the square root. So in other words, this cannot be negative. It has to be greater than, or it has to be equal to 0. So if we were to solve and add over the 5, that means the domain would have to say x has to be greater than or equal to 5. So if we want something that does not lie in the domain, that means I want something that is not greater than or equal to 5. This is greater than, this is equal to, this is greater than, is the only value that's not going to work. And if you try that out and you plug that in, you're going to see 2 minus 5, well, that's going to get you a -3, and you can't have a negative under the radical. Okay, so finding our values there. Determine the domain for each of the following square root functions and show an inequality that justifies your work. So again, think about what we just did. We said this has to be greater than or equal to 0. So if I were to solve, our domain is greater than or equal to -2, meaning any value that's greater than or equal to -2 would work. That's the same for all of these. So I know anything under the radical has to be greater than or equal to 0. So solving, divide each side through by 3, I can find x has to be greater than or equal to 2/3. Okay, and for this last, ooh, and I forgot a negative. Nope, I didn't. We're good here. We're good. Sorry. For this last one, same idea. It has to be greater than or equal to 0. So I am going to subtract over the 8. So if I subtract over the 8, I have -2x is greater than or equal to -8. And now I'm dividing through by a negative. Rules with inequalities, when you divide a negative, you want to flip your sign. Be careful with that. I've got 2 negatives. Negative divided by negative, I get a positive. 8 divided by 2, I get 4. So what this is saying here is any number less than or equal to 4 would actually work in that function. Okay, and lastly, we're going to consider this function here and use our calculator to sketch a function on the axes. Okay, so if we go to our calculator, and I'm going to shuffle through a couple of these here. This is the function that we have, and it says we're going to use our calculator to sketch the function on the axes. So I'm seeing here I have 2 zeros. I have 1 at 2, and it looks like I have 1 at -6, and then the graph is kind of pointing up. So if I were to go back, I have a 0 at 2, I have a 0 at -6, and then from there I see it's kind of like pointing up and away. So a rough sketch of what our graph looks like. So it says we're going to set up and solve a quadratic inequality that yields this domain. Okay, so same thing that we did before. All of the stuff, all of the goodness under the radical, I know has to be greater than or equal to 0. Now, we've solved these in the past. We have to think to yourself, oh, we have to factor this. So I need to find 2 numbers that would multiply to be -12 and would add to be 4. Okay, so factors that multiply to be -12 and add to be 4. How about a +6? And how about a -2? So when we set each of these, and now watch what I'm doing here. I'm setting these each equal to 0. I know it says greater than or equal to. We're just going to set them equal to 0 because we're trying to find the actual zeros themselves. So here's 1 0. Here's your other 0. That's not the solution. Those are the zeros. Notice what we had up above. I had a 0 at -6, and I had a 0 at 2. That's what we're trying to find. Okay, when we have solved these in the past, we've put these on a number line, and then we've tested. I always like to test 0. That's kind of a nice one. So if we were to test 0, we would have 0 squared plus 4 times 0 minus 12. And we're trying to see, is that greater than or equal to 0? And if we simplify, I get a -12 is greater than or equal to 0. And that's false. So that means that this section here is false, this is true, and this is true. And so then I would have to just graph my inequality. Keep in mind, it's equal to, so we have closed circles, and I want to point towards the direction of the true. So this, if I look at this graph and I look at this graph, see how that's making sense? That's where your graph is actually sketched up above. Okay, we'll do more of this in class, but this is just the introduction with square roots. If you have questions, please bring them in. Otherwise, have a great day.